Now, I want to remind you, Unit 2 and Unit 3 are the most important units in this class for preparation for your next class. Very important units. So the purpose of this class is preparation for Chem 1A, 2A, 3A. So the best preparation you can do is to do well on these next two tests. Okay, this is a study guide for test 2. This is probably, I should probably do this on Wednesday, but anyway. I'm going to give you a periodic table for two reasons. One, so you can do molar mass, and secondly, so you can identify certain places on the periodic table that I told you to know. One is, the four groups: the alkali metals, the alkali earth metals, halogens, noble gases, Lewis dot structures, nomenclature. Now, the nomenclature I'm going to cover in all the rest of the tests. Test 2, test 3, test 4. It's because it's something that's one of the weaknesses students going in. Balance equations, conversions, stoichiometry. We're covering simple stoichiometry today and limiting reactants stoichiometry tomorrow, which is much harder. So for you to get the most out of tomorrow's lecture, really look at today's stuff. There's also a worksheet that'll give you lots of practice on simple stoichiometry. And I'll show you that in a minute here. Now, the take-home test is the limiting reactant problem. They're more involved than the simple ones. It's about 4 extra steps over the simple one. Okay, so that'll be the test. And I've already done the test, and the test follows this study guide very closely. So make sure you got all your ducks in a row and checky marks and all that stuff. Okay, I'm going to put this as a file on Canvas right now. Okay. Now, these 4 steps are going to be followed today and tomorrow very closely. And step 1 is balance the equation. I will give you the unbalanced equation. Assume all equations I give you are unbalanced. So check every single time. Don't assume what I'm giving you is balanced. There's only one exception to that. That's on the worksheet that I'm going to show you. There's a problem on there with a really hard one to balance. So I just balanced it for you. But normally I always check balance. Okay, and then the normal stuff, what's given, what we're trying to calculate, and then there's setup. The setup is going to be just like before. It's going to be a bunch of conversion factors. It's the name of the game in chemistry, physics, engineering. Conversion factors. Okay, and stoichiometry is the mathematical relationship between the reactants and products. Mathematical relationship. That means I'll give you something, and then I want you to know what's going on if it's with something else in the problem. Up to this point, we've not done any reactions. It's always been, we're just renaming that one commodity. Now, as commodity changes, So we have to, that's why we balance equations to take up that change. Okay, so this is a typical problem. Okay, 15 grams of water is formed. How many grams of methane was consumed? Okay, so I'll give you the equation of the reaction. Now in 1A, 3A, I don't know about 2A. I haven't taught that here. They're not going to give you the reaction. You have to figure that out based on the words from the problem. By the way, this is combustion. And normally, unless you're a space engineer or an X-15 engineer, I have a friend that used to work on X-15s in Edwards Air Force Base. You work with non-oxygen. Basically, combustion is a fuel plus oxidizer. Fuel plus oxidizer yields oxidized fuel. So methane, CH4, is the fuel, O2 is the oxidizer, and oxidized carbon is CO2, oxidized hydrogen is water. But normally, we don't talk about fuel and oxidizer, we talk about combustion, we talk about oxygen plus fuel, gives us water and carbon dioxide. Like when you burn gasoline in your car. When you turn on your water heater where it burns methane, if you have a gas stove, same thing, combustion. Okay, so step number one is balance the equation. Now, again, I'm going to be giving you the equations. So this is the equation. So we have, I'm just going to balance it really quickly for you. Okay, all right, so what's given? 15 grams of water. What are we trying to calculate? Methane. Grams of methane. This is just like before. Given on the left, calculating on the right. Okay, so now though, we've got another little glitch in all this. There's an extra step because we have a reaction. Okay, so first thing is first, we change everything to moles. So we convert water, 15 grams of water to moles of water. Given as to cancel. And water is going to be one water is going to be, two H's is 202. One water is 16, so that's 1802. periodic table. Two hydrogens, 101 apiece, plus oxygen, which is 16. And decimal numbers up there. Okay, now we have moles of water. We need to go to moles of methane. That's where the balanced equation comes in. That is the ratio of the coefficients from the balanced equation. So water has to cancel, so that goes on the bottom. Methane is on top. From the balanced equation's coefficient, water is 2, methane is 1. So water cancels. That's the new step. Now that we have moles of methane, we need to go to grams of methane. Okay, methane is going to be 1 carbon at 1201. 4 hydrogens, that's 404. So that's 1605. Okay, so every stoichiometry problem has these 3 parts. We take the given to moles, mole ratio from the balanced equation, and convert moles over to what we're trying to calculate. In this case, grams. Every single problem. Okay, so if you have a stoichiometry problem, throw it into these 3 steps. Okay, now we just grind it out. So if this problem is worth 10 points, you're looking at 9 points. No calculator needed. My battery is low. So let me redo it. Okay. 3 sig figs. Now let's go over the conversion factor we've learned up to this point. So we've got Avogadro's number. Gas at STP, 22.4 liters per mole at STP only. And then the molar mass from the periodic table. We have to work with. Okay, are there any questions about this process? Now I've gone from very simple conversions, unit 1, and we've made all these little steps. In 1A, you're gonna make one big step. You can be doing this the first week of class, and moving right along. Typically, when I teach 1A, this comes up first week, unless it's a slow class, and it'll be the second week, but it comes up very fast. Summer comes up even faster. In fact, if you ask me what I recommend for the summer, is I never recommend a science class. It goes too fast. I recommend you take a GE over the summer, except for psychology. Is it 6 chapters a week?
No.
40 pages a week in our psychology class. Moving right along.
Sorry.
Okay, so any questions about this problem? Okay, so I'm gonna do a whole bunch of problems today. And the reason I'm gonna do a whole bunch of problems is I want you to, I'm gonna stop a second here though. And I'm gonna go over to Canvas files. Go to unit 4, stoichiometry.
Oh,
And there's a whole bunch of practice worksheets.
This is so,
And just basically what I'm going over today. Turn around and slap him upside the head. There. Okay, my point in this is, and then I have answers, okay? Bottom line is I have lots of practice for you.
file,
Files, unit 4.
file.
Yeah, unit 4 used to be the stoichiometry. And I've got to rename all this. Yeah,
The geometry problems, you know, the lab, or the other worksheet that you told us that had the answers. So if we were to do practice, would you recommend it in a notebook or scratch? Or
is it either one is fine.
doesn't matter,
Yeah,
because I don't have an extra notebook, so.
scratch paper's fine. Too bad you didn't live in my building. I have so much scratch paper. I mean, literally throughout about this month, I'm not exaggerating. Old tests and stuff that are good. In fact, I even put them in through my printer. So, so one side is bad, but the other side's good still. So I just run through my printer. I don't waste any, well, I try not to waste it, but, paper's fine, scratch paper's fine. Main thing is do the practice. Okay, also there is a dry lab. Lots of equation balancing practice. Some on gases. And down towards the bottom, I have limiting reagent practice problems. That's what your take-home problem is going to look like. Very similar to one of these. And I'm going over this tomorrow. Between practicing, me going over tomorrow, you should have a really good, solid footing for the tests. Okay, if you go to lab related, there is a dry lab called Dry Lab 9 Stoi. I'd recommend practicing on that one first, because that's going to be a dry lab, so you get credit for it. And the answers are there also. Now, the reason why I put the answers in, even though it's a dry lab, it's really important you know how to do this. And I'm stressing it, it's really important. And sometimes people, they just need a lot of practice and all of a sudden it's a aha moment. Oh, I get it now. There's a pattern here. And the pattern is reproduced every single time because we're doing unit cancellation. Okay, so any questions about these extra worksheets for practice? And if you get this right off the bat, you got to do the dry lab anyway. So this one here, this dry lab 9 story, that's a replacement for dry lab 9 on your packet. Okay, so let's okay. 45.6 liters of water vapor formed. How many liters of methane gas were used? Standard temperature, pressure. Now, on all these practice problems, I'm going to use the same reaction, so we don't have to keep writing it down and balancing and all this stuff. But normally each problem is going to have a different reaction, so keep that in mind. All right, it's already, equation's already balanced. What's given is 45.6 liters. We're trying to calculate, this is water. I'm trying to calculate liters of methane. Okay, we're gonna use 22.4 liters of methane at standard temperature and pressure. For water to methane. So water's on the bottom, gotta cancel. It's 2 to 1 again. Now, in some books, they'll say they'll put mole here. So either one's fine, with mole, or no mole. They can't sell that anyway, but just to be consistent, Aaron, do you remember in the textbook where the ratio, did they put mole over mole? Yeah, I don't remember either. Okay, then we need to convert to liters of methane. Okay, now, before we grind this out in your calculator, notice the 22.4 is on the top and the bottom. So that means the 22.4 cancels. So we have 45.6 divided by 2. Again, 3 steps. Convert to moles, mole ratio from the balanced equation, convert what you're trying to calculate. Yeah. Your hand raised.
8.28.
Yeah, it's always been 22.4. Unless it's non-standard temperature. Then it can be anything. So when it's at standard temperature, it's always 22.4. And when you get into 1A and 3A, it's never going to be 22 or never standard temperature pressure.
I want 20.8. You put 2.8.
Oh. Yes, I see what you mean.
Yeah, it's really bad. These things happen.
All right, thank you.
Yeah, it was really close to 22.4. Yeah, thank you. All right. Questions about this? Now this one is how many molecules? But let me write down the equation again. Okay, so we're given is 34.5 liters. At STP. Now we're trying to calculate how many molecules of water. Carbon dioxide, I mean. Okay, first step is liters to moles. Now we're going carbon dioxide to water again. And now we're going, this is a little tight. Let's see, can we move this over?
So we are some.
Calculator needs to be recharged.
This is that.
Let's see.
It's the same.
Four. Would it be 3.45 divided by?
It's divided by 34.5 times 602 times 10 to the 23rd,
Oh, okay.
divided by 22.4 divided by 2. 2 divides on the bottom.
So. Fine, and then, yeah, fine. Fine. 22.4 divided by 2.
You're gonna divide twice though. You're gonna divide by 22.4 and divide by 2. Yeah,
So ever setting up your convert factor. In the original equation that's given, you're never putting from the left side of the equation. In your conversion factor, you're always putting from the right side.
whatever you start with is on the left. And that's the given.
So where you put CH4 plus 2O2. For the actual equation. Before we even did the conversion.
Okay.
So you never put that, you put the 2H2O plus CO. I'm just like confused what you're putting into the conversion factor every time. I get the rest.
Okay, well, it doesn't matter what the reaction is. Because you're gonna have more parts to the reaction than what's in the problem. because you're only using two things in the problem. So you find those two things after you balance the equation, find those two things in your reaction, and that's all you're using. Right here. If there's nothing there, it's a one. So this would be a one and a one.
I guess what I'm trying to ask is, you're not putting in P84 and you're not putting in 202, you're putting in the other side.
Yeah, so just find the given in the reaction, find what you're trying to calculate, and that's all you're using. I mean, this equation could have 10 items in it, doesn't really matter. We're only working with two of them.
So for the answer, when I on that, so
Let me do it again. 34. Yeah, because you're going to three sig figs.
oh, the
So you're going to fourth place in that round. I do make mistakes though. Like she was pointing, so.
I was just redoing the math the second time that I have it.
Okay, any questions about this problem? Again, pattern, yeah.
You heard the question, just think the word and not the book. How would you, are we expected to remember that it is CH4?
Yeah, in 1A, they're gonna say methane is combusted. All they're gonna say. And you know, oh, that's a combustion reaction. That means it combines with oxygen and produces carbon dioxide and water. That's all they're gonna say though. Methane is combusted. Yeah, and they'll tell you what to know. And what's the formula. Or at least if I was teaching you in 1A or 3A, I would say know these. And know what a combustion reaction is also. Okay, so let's this one's slightly more complicated because I'm talking about kilograms rather than grams. So we're starting with 23.4 liters. Same reaction now. Same reaction, so the reaction is going to be methane plus 2 oxygen gives us 2 waters plus 1 carbon dioxide. Okay, we're starting at 23.4 oxygen. Now, also, notice I said oxygen gas. In your 1A and 3A, they're just going to say oxygen. Because oxygen is one of the 7 diatomic gases. But I always like to say, because oxygen doesn't exist by itself in nature. It always teams up with another oxygen or another carbon or whatever. It's never by itself. Oxygen by itself is very, very reactive, very unstable. So you never find it by itself. So keep that in mind. Whenever you see the word oxygen, hydrogen, nitrogen, they're all doubled. They're H2O2, N2. And all the halogens, F2, Cl2, Br2, I2. All the halogens, same thing. Okay. All right, so 23.4 liters. And in this class, the gases are always at STP. So that's 22.4 liters per 1 mole. And now we're going to carbon dioxide. So that's 1 to 2. Oxygen needs to cancel, liters needs to cancel. Now I'm going to end up with kilograms of carbon dioxide. So we first have to go to the main unit, which is a gram. So carbon dioxide is 401 grams per mole. So moles cancel these as with grams of carbon dioxide. Then we need to get over to kilograms. So everything cancels except for kilograms. So I call this simple stoichiometry because limited reactant is not simple. So Sierra, do you have a question?
Yeah, so on the test, will we have to show us, so you see where it says 12.01 and then 32, and then we got 44.01. Would we have to show that math and all of that on the test? Well,
You won't have to show how I got the 4401.
Oh.
You have to write it, you probably have to write it down anyway to add it up. So just put it by the problem. In fact, it would be good if you did it, because if you made a mistake doing your molar mass, say you only put in 1 oxygen. So you got the molar mass wrong, but your setup is right, except for the molar mass. I could give you more partial credit that way.
Okay.
So we actually, hindsight, do your math close to the problem.
So like the problem, like, is this how many kg? You know, well, so we would have to write, like, break it down and do, let's just say it's a CH4 plus. We'll have to write that and then do the table and everything else, and then we get our answer.
Yeah, so make sure you show your balanced equation and then the unit cancellation. All that's part of setup. 90% of the points also. All right, so let me show you what a limiting reactant problem looks like. Now, what we've been doing today so far, we've had how many givens per problem? 1. If you have more than 1, things get complicated. And one of the givens limits the reaction. So this would be how many grams of water produced if 567 grams of methane are consumed and 523 grams of oxygen are consumed. 2 givens. That's what a typical limiting reactant problem looks like. Or it could be three givens. You won't have three givens in here, but it could be 3 or 4 givens. It doesn't really matter. My friend who was a general manager of a Union Carbide plant making pesticides, he had 10 or 12 givens he was always working with. So the essence of this problem was very simple. Let me give you a very concrete example. If I have, let's go back to bicycles again. If I have 10 frames and 10 wheels, how many bicycles can I make? Why 5? Yeah, you need more frames to go with the 10 wheels. So what's limiting the reaction, frames or wheels? Wheels. Because it produces less bicycles. If we just looked at wheels, we'd have 5 bicycles. If we just looked at frames, we'd have 10 bicycles. So what produces the most product? Or excuse me, the least product? Wheels. So that's the limiting reactant, wheels. I'm going to do with chemicals tomorrow. Let me show you what, just to give you an idea of why I want you to study this stuff tonight. That's the limiting reactant problem. Quite a bit more. So if you don't understand today, tomorrow is going to be ugly. So tonight, put some time in on this simple stoichiometry. It'll make tomorrow's a lot easier. So you look at this problem, we've got 2 givens, 23 grams of ethane, 34 grams of O2. 2 givens. So basically what we have to do is calculate 2 products. The 19 is less than the 52, so the oxygen is limiting this problem.
For both units, their own independent conversion. And then whatever answer is the least amount, that will be your final.
That'll be part of the final answer.
That'll be the one that you circle.
It's part of the, yeah. So the other part is how much do you have excess ethane? How much? That's the third calculation. And then the fourth calculation is after you calculate that, then you have to subtract from how much you started. 4 steps. And everyone is the same though. So if you look at so now your take-home problems look very similar to this. Okay. So we want to know, write the balanced equation. This is simple methane being combusted. 15 grams of methane and 15 grams of oxygen react. How much water is formed? There are 2 givens. So here you're going to write two calculations to determine product, which is water in this case. What's the limiting reactant based on which product is less? How much non-limiting reactant is left over? You have to do a third calculation, determine how much you used, and then subtract that from what you started with. That'll be the answer here. Now, sometimes there's a yield question. I'll say, what's the percent yield? Now, what you're calculating here is theoretical yield. I'll give you an actual yield and you do a ratio and convert to percent. Same thing. Okay, so here's a reaction. 30 grams of ammonium nitrate. That's this. The first one. 50 grams of sodium phosphate. It's the second one. Two givens. Same thing. Balance the equation. Figure out what each given will give by itself on product. Then find the excess. And then some of these have yields, percent yields, but they're all the same. And did I give answer? Yeah, gave you the answer. Okay, and this one I actually say if 1.7 grams of hydrogen, do I have to say gas? Hydrogen, remember, is H2 is produced. What's the percent yield? So you go actual over theoretical times 100. Okay, so that's what I wanted to cover today. Simple stoichiometry. And I really like it for your benefit if you study this tonight. It's simple. Do as many problems as you can. And tomorrow we'll go much more, it'll be much clearer what's going on. Now, again, you will cover limiting reactants in all three of the chemical classes. 1A, 2A, 3A. All of them have limiting reactants in it. So it's important you're exposed to this. Now, I've given you the limiting reactant problem as a take-home. So you have lots of time. You have a week to do it. Whole week. All right. And then today is for Monday people, it's dry lab.
That might be. Same. So, I was kind of so. What was the lab that you wanted us to do for that? That is. Yeah, so we're talking about. When I guys doing
Yeah, I talked about that today.
Yeah.
5,900. It's a good workshop to do though. No. Makes sense. Why did my green?
Oh, what am
Okay.
Nice.
Ask you. It's fine. I thought that started at 12 and. I lost. I was on vacation. I'm gonna blame that. I'll be back to 12 fall and spring. I'll see you there tomorrow.
Oh, sorry.
Let me do something.
Oh, so.
Okay, let's. Thank you.
Like really
You're.
I'm like everything. Well, even if like your time is like what half ago. It's kind of amazing. Like I look forward. Like the skin look weird. Not like layers.
So.
Yeah.
So, but.
Let's go. Ready? Yeah. Actually. Yeah. Let's go.
And you're all these.
I want to get you kind of better. Look here. But
Story.
I don't think the balance equation. I mean, I kind of get. I mean. What we got? It's like this.
They take like walk. And they take a glass. And then.
All the songs around have a microphone, say, the original private topic.
No. When they watch out for.
That was the balance. Oh.
And they're real, there's white on the back, space. So.
All the way through. Sorry.
So for the dry left, we just do the aspect.
Yeah, that's fine.
You're like.
Is that your question? You can always add stuff, you just. Don't miss it.
So if we get any of those wrong, does that?
I'm not,
Thank you.
because they're not even more supposed to read.
So, for the Lewis dot structures, I'm guessing we're doing that on the test, right?
They are tests.
Okay, so for the dots that you gave us for certain elements like carbon, nitrogen, they're There's only a few of them, but I know there's more because I looked them up for like the lab, the dry lab.
You only need to do, remember carbon. Carbon has how many singletons? Four. Here you go. 4, 3, 2, 1. Nitrogen has 3, oxygen has 4. Fluorine has 1.
Yeah, but do you only put the singletons, or how would you know how many?
Well, you're gonna put the pairs in. But as far as the singletons go. 4, 3, 2.
So how would you remember how many pairs, or how would you get to how many pairs each nut has?
We have to have an octet in the end. So. Carbon's got 4, period. No double.
Yeah,
Okay, nitrogen has 1 more electron, so it pairs up one of the singletons with carbon. That's why it has 1 pair. Oxygen has 2 more electrons of carbon, so that means there's 2 of them got paired up, so that's why there's 2 pairs. Fluorine has 3 more than carbon, so it has 3 pairs.
so it's the same for bromine.
Yeah.
Oh,
Yeah, the families, that's why the chemistry is the same in the group. It's because the valence is the same.
because I don't think that was emphasized as much because I was so confused when I got to the dry lab for the Lewis dot, like bromine. I was like, I was like, I don't remember him saying much about how to get to that. How to get to the Lewis.
Those are the easiest ones. Those wasn't, yeah.
Yeah. All right, thank you.
Okay. So. Everyone in these, the equation's gonna have more than we need for the curve. Every single,
That makes sense, though. I was thinking like, where are you like pulling these out of, because you have this long equation, and I'm like, is it just like selective, it's like selective or da? So then, once you find out what you're solving for, which is these two, this problem. You'll then take the molar mass of both, add them together, and that becomes a converted.
each one of itself is. Here,
Well, right here they are, yes, but then,
right here, too. Okay. This conversion factor is just a ratio. No grams involved. Just a simple ratio.
right, because it's not curved, it's plus.
Well, in front of it, the coefficient in front is an integer. One,
If there's a one, yeah,
and that's all you're concerned about, those integers, for the middle one.
so then I'm confused then, because you do add these together and it creates a new conversion factor.
Now, this conversion factor is for what they come up with. So,
But it's these two added,
no. The outside is 1 carbon,
carbon is 12.01,
carbon,
and it's carbon two, so you have 2 oxygens.
32. This is an acid.
Oh my goodness. So why are you only doing it for carbon? Not or H2O. I understand now that CO2, the molar mass is
Reason why I use hydrogen is not in CO2.
no correct, but how many kilograms of CO2? So I don't care about H2O. I care about CO2 and finding its molar mass because that's what it's asking. It's not asking for H2O.
Said,
How many
so instead
how
of,
many grams of H2O?
very starting with the, that's why we use the 24. Sometimes you start with gram, then you need a molar mass,
Right, and then it's Avogadro number.
you put it out. Well, that's fine.
So if like, let's say this was reworded and it says,
how many grams of H2O are produced in 23.4 liters of water. Then you would still have this same conversion factor, but H2O would be on top and CO2 would be on the bottom, and then I find H2O's molar mass and put it over one. That's what was confusing me.
So let's go to gram. What's the most?
I have gram. You expect to go in.
How much methane is consumed? What is
Gram.
so what's we're using one for each side. It does not matter. You can- Right? Both of them.
I see. 15 grams of water is formed. How many grams of methane gave for was consumed? So then you have methane over water.
This, whatever you want to do, that's the top. Because it won't, otherwise, what you're stuck with is the cancer.
And the reason it has two H2O is because you balance the equation
Yeah.
higher. And the one is from one CH4. Oh my god. That just made my life so much easier. Thank you so much. Think about it, it's like, I'm just gonna write it down, because that's what people are doing, but I don't understand. Sports today.
And you put one zero.
Okay, yeah, that helps a lot, thank you.
And then you do a whole problem since. You know. I mean, if you're.
No, this is my
Yeah.
to do this.
Wednesday. So
The
did
way lab related,
you just do like that?
study.
It's the Lewis song.
Bonding.
Okay, so we're not doing the last.
This is just the first two.
Yeah.
Thank you so much for.
And then you single. Carbon, so you can figure out all the rules are similar.
Yeah.
So
You're
carbon
gonna
is four.
put down the
So
study
carbon is
guide
4 single.
also.
Actually, it's 3 single.
The study guide.
It's 2 single. Or you can one. And everything down.
Okay, so then
Huh?
columns.
Yeah, and then.
No, I want to have it as a
total
document.
valence electrons, so 4 outer valence electrons, 5, 6, 7, but the singletons matter. Okay. So fluorine is gonna be 3 doubles and 1 single. Along with everything that's from, so CPR, bromine's in there a lot.
Okay.
It has 1 singleton and 3 singletons.
I think you gather it just from.
I asked.
Bromine has 3 pairs, not
Three
3
pairs.
singleton, 1 single.
Yeah, 1 singleton.
PR.
PR 30. It's under fluorine.
Okay.
Because it's liquid at the like 15 mercury.
Yeah.
It's a lot of fun looking with your.
Could you be my calculator?
For 1 hour.
Oh yeah, I just got the yield. So it's just the limiting factor. Let's see.
Yeah, I know what that is.
Yeah, but I got I looked at the thing on my phone. But yeah. Well, this is just like.
Oh, okay.
Well,
So you
my
turn
daughter-
O2 limiting
Flaky?
factor to how much of the.
I suggested we.
So you turn the O2
her place.
Right.
to see how much
Have I
methane
heard
you
from her
need for
yet?
that much of.
No, heard from my son-in-law.
So if
No.
you
That O2 is the limiting.
Like
factor.
your principal,
Well, you know,
and there's some
this
benefit.
is 12, and this is
Like
so this is
a barbecue where we're
So only
really.
three, the
It's
two
like,
point nine
oh my God,
five.
they're gonna have to barbecue.
Yeah.
So for this question, this is big. But if you wanna keep going, see how much.
Texas
methane
and barbecue.
Like,
How much methane we need for use?
yeah, it's how much methane is used.
Oh, okay. Oh, okay.
I've been to San Antonio.
Translate the O2,
Hey, what?
how much O2 is that?
All the
You
marketing.
translate that into grams and.
Trade shows.
So we use
For
3.31 grams.
So bounce from
All
all.
things we're not using.
Yeah.
Ribs
We're not
place
using it.
in Boston,
So that's, and
Jay Leno store. Ribs from,
Uh-huh.
load in.
then, yeah, and then the
Oh my
next,
God.
the taking are just this, and 15.
My real-
Yeah,
My dad's side.
Yeah,
It's full of-
15 to 15, I think.
So I.
But this is the same question,
you ever get the chance to go to Pinkerton, go to Pinkerton. It's our favorite, and every time we visit, we're like, we stop in San Antonio. I know it's 3 hours away, but if we could just make a quick stop, that'd be great.
Yeah,
Anyway.
I like,
It's just.
I was born in Texas. I was born in Lubbock. And, but, I've been to a lot of different places in Texas. I mean, all over. And my favorite two places are Austin and, San Antonio. It's called Hill Country.
I think that would help.
Yeah, the limiting factor.
But I also think that college stations
Like,
really.
if you wanna know how much.
If
But the two places that we've been that we haven't been to a lot of people, but
Like that's.
and like Houston so much.
Or the first.
And where's there's like the
Yeah.
things like out there
Let me project it.
and
Like if you said and 5 to CO2, you would have.
There's a lot of little tiny towns in Texas.
This was one thing.
and it's like
No, but it
there's like
okay, so it pretty
many
much has to
churches
be
on the way, like-
because it has the height.
Every corner of church.
Yeah. And then you get to him
Because
too.
you can
and
kind of figure it out before you do it.
like,
So
like
there's
totally
two.
break down.
So you're
Find the ratio.
Type of deal,
One.
and then you get.
yeah, but like you can figure it out like generally like the numbers are really big. So like
Like I would not.
everything that affects it is polar mass. It's gonna have like 3 halves times this. But this is also 2. So it's gonna be like
It's south of
uh,
Arkansas,
see it's dividing by
Missouri,
2. This is not gonna divide.
Yeah.
southern part of Illinois.
I think I'm really happy we got gas.
And then that's why. And then
Gas is cheap in Texas.
that's how you understand that this is gonna
I was
be
like
less of
$2
a.
special instead.
If you're giving the same
It was the rental.
that CO2, you're
You
not
just want one.
You're gonna put gas.
Yeah.
Yeah, but you can understand beforehand it's gonna
But
be
yeah,
That's what I'm saying, yeah.
there's a lot of.
because the 2, mostly because of the 2. But you can understand you can do that.
If.
If you do.
Well, no, you don't need to, so it with the ratio.
The ratio,
So you just have something that.
you have to do this ratio. You have to, and well, you have to have the more masses.
Oh, I know, but you already.
And
You
then-
actually have to use the
Yeah,
ratio.
yeah.
The ratio. What, yeah. You were going. Less
Then
than one of them.
back,
you're
back,
less
right.
or
Cause
more
they're walking towards.
than the
Right.
ratio. You just have to put it. That's what
Okay,
we're
I
You don't even have to do that. Figure
And
out.
I.
But they knew they.
But you need to figure out the ratio, you
Yeah.
need the math.
But
Yeah.
the-
We're not, they're still.
No, totally one is not exactly, it's not all of it, you need them all.
Yeah.
So if this is C3O2, this will be the.
No redeeming factor, other than those
Yeah.
areas I was telling you about, and the little suburbs around.
Yeah.
So it would
Like
be
my,
plus
my
36.
cousin lives in Pflugerville,
3 C's.
Oh, but you're talking about CEO the ratio.
which is near,
CO3.
Oh, that's not that instead.
a suburb of Austin.
Yeah.
As much as I do like Austin, as much as
But
I.
if you add like a bunch of
Austin is really like the.
and then it would be a
Texas
C.
because everything's really expensive.
The metropolitan, or the metropolis is more like California, you know, the
Sure.
Dallas Fort Worth.
Yeah.
It's like one big city.
Well, I mean.
There's no, nothing in between. It's not paved over
Yeah.
at all. And then El Paso is another one that has no Texas feel. They don't even have an accent in El Paso. Yeah, it's basically New Mexico.
The Mexican food though, because I was like, really fun. Feel like we're gonna get real good Mexican food, like in San Diego, you can get really good Mexican food.
Yeah.
And it was Tex-Mex.
Right.
Like there was like corn in almost everything, and like everything was sweet, and I was like, this is spicy. This is not the Mexican food as it's okay.
Yeah, they eat a lot of pozole, particularly the more western you get in Texas and yeah, particularly El Paso. I mean, pozole is the main Mexican
It's
food.
like,
Yeah, or stew.
it's like stew.
No, it's got what is that?
Sorry.
Corn.
Question.
I don't.
Oh, okay.
It's the corn that's got what is it? It's treated with slate lime. What's
Amazing.
that called that? This is what happens when you get old. You have these blocks.
So you think, I think it's the, what Keeping good in it. I don't have service in this building. Hi.
Hominy. And hominy is corn that's been treated with lye. Well, when you see the real one, though, it doesn't look like a garbanzo.
Okay, never mind then.
It's
You're
kind
not
of,
very
garbanzo beans are real round and hominy is not. It looks just like a swollen corn kernel. Yeah, and it depends on,
That's really cool.
yeah, and see, this is the hominy there.
You can make it with pork and chicken.
Yeah, normally, the traditional ones with pork. And then what's cool about it is you put a whole bunch of, stuff on top.
So this is like the Mexican version of ramen, then essentially. Ramen, I put
It's similar to, Vietnamese spa,
pho. Yeah,
more so than,
ramen.
yeah.
See, I can't get on board with pho yet, though.
I don't like Vietnamese food.
I love the noodle in it, and I kind of like the broth. I can't get down with the boiled meat though. Can't get down with boiled meat. I tried it, and the texture is different than like cooked on fire meat versus like hot liquid, and I couldn't do it. Couldn't do it.
But they have all different kinds. They have shrimp.
I just do noodles and broth at that point.
Yeah, but I mean, the broth can be shrimp broth, chicken broth, pork broth. I mean,
I normally like a seafood stock. I don't know. Chicken freaks me out when it's cooked by other people. Doesn't matter if I go to KFC or if I go to like a Mexican food place, chicken freaks me out because the high possibility of like getting food poisoning from chicken versus beef is like super high. So I just never eat chicken.
well, one of the reasons why you should never wash chicken is because when they defeather it, the chicken's dead. Feather it, but its feces go all over the place. So if you wash your chicken and you splash water on your counter, you're splashing lots of bacteria on your counter. That's why you should never wash, because heat will kill all the bacteria. Just so it's visibly looks good, good to go.
Look at chicken breast.
Hmm?
Look, chicken breast.
It doesn't matter what chicken.
Oh my gosh, I wash it every time. And then like afterwards I set it down and I do this with my hands. I saw it all over my kitchen.
Yeah, it's it is chicken.
Talk to your ear off now about it. Holly, I gotta go.
Chicken.
I gotta go.
Tell your boyfriend about the shooting though. Well, just tell
And then
him. Bye-bye. Her boyfriend's a firefighter.
Oh, and one item.
So wait, what's the one for today?
It's
The lab.
5.
Oh, we're doing is it 5 or 12? I think it's 5.
We
Well,
did
that's
5.
supposed to be missing.
Huh?
We did 5 on Wednesday.
Well, they're doing 12 then.
It's whichever one you did. I did that one.
Yeah, and then it's you're just doing the low structures in 12.
Just that first part, not that the last half of it where it's like
No, you do the whole
Angle.
thing. You do the whole yeah, the
that, the right half, yeah.
yeah, you're not doing the right half unless you want to. It's the reason why I'm not having you do the right half is I want you to focus on Lewis structures.
Okay.
Because that's a weak spot going into 1A.
Is that like how we skipped the acid in lab 5?
Correct.
Okay.
So
So
are we
just,
gonna learn acid?
Hmm?
Are we gonna learn acid?
That's the next unit on solutions, because acids and bases are solutions. Then there's neutralization reaction, which is another reaction. You know, we have combustion so far. We'll have neutralization, which is an acid and base together. Then we're going to have single replacement, double replacement reactions, and we have synthesis reactions. There's a lot of different types of reactions.
is it important to note the type of reaction?
Depends on your teacher.
Well, I meant like in terms of solving any of the equations we will, or balancing any of the equations. Does it matter what it is, or
No.
just that it,
If you're balancing, no.
yeah, it wouldn't just,
Yeah.
But do we figure out like the molecules by figuring out the reaction type? Like combustion, this was combustion. Is there like another type that has water and CO2 or water and?
No. No.
Okay.
In combustion in general, though, is you have a fuel and you have an oxidizer. And the oxidizer oxidizes each element of the fuel. So with methane, we only have carbon and hydrogen, right?
Yeah,
Yeah.
and then that has to turn.
Yeah, so the hydrogen oxidizes water, carbon oxidizes carbon dioxide, or carbon monoxide if you don't have enough oxygen, or just plain carbon by itself if you don't have enough oxygen to go around.
Are there like other types of reactions that use methane as a reactant?
Well, organic chemistry, yeah, a lot of
And then like what's a potential output?
potential what?
Output, sorry, it's a product.
If you're using,
Methane.
yeah, well, you can do something called a halogenate methane, which means put chlorine on it. So you end up going from methane to methylene chloride or any of the chlorinated hydrocarbons.
And what's that reaction called? When you add,
Just halogenation.
when you like add a thing.
Oh, it's called an actually, I
Addition
hate to say this, it's called an addition reaction.
reaction.
Because they have substitution in organic chemistry, you have addition reactions, you have substitution, you have oxidation, reduction, there's a number of, and it just, a lot of it is what's going on with electrons.
Mhm. Yeah, everything has electrons.
Yeah, not so much protons until you get to nuclear chemistry.
Oh, right. Yeah.
Then it's big time protons. Because when you when a chemical gives off radiation, there's all different kinds of radiation. There's alpha, beta, gamma radiation, for example.
Yeah.
Alpha is a helium nucleus, 2 protons, 2 neutrons. So it's 4 particles. That's the heaviest. Beta radiation is just an electron coming off. And gamma is just pure energy with no mass.
Does that mean like a mass turned into energy? And there's no mass?
Well, when the nuclear reaction happens, usually there's a mass
Yeah.
loss. And the mass loss is what's the gamma radiation.
Yeah.
It's converted to E is equal to MC squared.
You know, the thing I found funny is nuclear fusion. You know, it's like masses coming together, but you actually lose mass, which is really funny. It's like you would think when you're fusing things, you don't lose mass, but that's how you get the energy.
Yeah. Well, it's
Right.
It's 2 plus 2 is 3. It's
Yeah.
It's more, but
Yeah. It's more, but it's
not
losing.
it's not the sum of the two.
Mhm.
Yeah. I'm trying to think of a real simple example. 2 plus 2 is 3.
It's like fission would be like, yeah, it'd be like fission's like the opposite, right? It's like 3 equals 2 plus 2.
Yeah, fission is where it splits apart.
Yeah.
And see, the middle of the periodic table is the most stable, like around iron. So if it's less than iron, usually stuff comes together. If it's more than iron, stuff comes apart.
So uranium usually comes together.
Uranium is a lot heavier than iron.
Yeah. Okay.
So it wants to be like iron,
Uh,
which is more stable than it. So that's part.
I mean left as in gets larger or left as in.
Oh, it's got 92 protons and electrons.
Mhm.
So then it becomes barium and krypton. When it splits it, well, there's different splits, but that's the most common one you'll see.
Mhm.
And then those can further split.
Yeah.
It's all stability though. It all wants to become more stable. Otherwise it won't happen.
And it's like entropy was what caused like all the different atoms because everything wants to be hydrogen, right? Isn't that what's stable? What is stable? Like what would be the most stable everything? Like what would ever I don't know. What is the most stable thing?
In the middle of the periodic table.
Like if everything had a chance to like go to its most stable property,
Yeah.
it would become iron,
Ish, yeah.
ironish, cobalt,
Area.
iron arrogant. Because like everything started as hydrogen, and then now it's
Originally, yeah, everything's hydrogen. Actually, in the beginning, it was just protons, neutrons, and electrons.
Oh,
I don't
yeah.
like.
And a
Yeah, it's
neutron,
the energy.
yeah, an energy, neutron has got a electron embedded in it and a proton inside. So now, people say electrons are only around the nucleus. No. Electrons are also been embedded inside of a neutron. For example, well, they're neutral because plus and minus,
Yeah, so in that.
Oh, it's a proton, like, and
an electron, yeah.
Uh-huh.
So if you add up the mass of both of those, it's the mass of a neutron.
oh, so is that how you figure out the mass of an electron? Is a neutron minus a proton?
No, they do it all this sophisticated ways, but if you look at the mass of all three of them and you add up proton plus electron approximately equals a neutron.
Hmm.
There's some,
Is that how we figured out that a neutron is a proton or is an electron inside a proton?
no,
Was
They-
the
they-
neutral color is that?
no, they figured it out by looking at what happens when a neutron breaks apart. Nothing to do with mass. And then so what happens if you lose an electron? The electron comes from the neutron. What's left over after you lose an electron is a proton. That means the element changes. It has one more proton, right?
Wait, so it doesn't lose like a valence electron?
No, it's coming from inside the nucleus now.
Really?
But then wouldn't it make it?
A new element?
Yeah.
Yeah, but it would also make it unstable. Oh.
Well, it depends.
Yeah, maybe an ion or whatever.
And so,
And then it wants to do something.
Because it would be a negatively charged.
But if it was
No,
already one,
it would
if
be,
it was already positive, then it would be
Neutral. Well, I just mean it would be one less.
but if you started neutral,
Yeah.
okay,
if you start.
and you had beta radiation, that means losing an electron. That means the neutron is going to be converted to a proton. That means it becomes a cation and a new element. Because protons change.
So is that how we get new elements?
It's yes and no.
We try and take an electron.
Yeah, if you go in, did you buy the book? I was gonna say, you go to the nuclear chemistry section.
Hmm.
It's really interesting, but you can find that online all over the
Yeah.
place. All over the place. So, did you do a computer science class?
Yeah. Well, this is Code Wars. It's HPE does it. Oh yeah, Sierra College did a coding event. And I tried signing up the day before, and then you can't do that. And then I didn't do it.
Well, I was gonna say, my friend teaches high school in, trying to think what high school. Anyway, he has one of the robotic dogs for the summer. And he teaches at one of the community college. He teaches chemistry, but he also teaches computer science. And so he's programming the dog to do various things.
Oh yeah, computer science teacher. My computer science teacher is a chemistry teacher. You were a computer science teacher, and now you're chemistry.
Yeah. I taught programming.
Mhm.
I taught Pascal.
It's a like
I taught it in the 70s and 80s, okay?
Yeah.
Things change with computer science daily, much less 5 decades.
C is becoming a bit again. People want C, jobs want C. That's what I think.
In my day, they wanted Fortran. When I was in graduate school, you've programmed, right? Okay. You know what? When you have a loop, you have to have some way of getting out of it, right?
Yeah.
So you have a Boolean statement, true or false, and that exits, right?
Yeah.
So I had this now, when I was in graduate school, no calculators, only mainframes, big giant ones. And so you have to write a Fortran front end for this statistical program to run.
Mhm.
So I had a loop. And in the loop was print statement. And my Boolean never was true. It was always
Oh
false.
my god.
So, and to do it, it was in the library. And then you submitted your job, it was cards, punch cards, put your cards in, and you came back the next day to get your printout. And I had a little note, it says, see,
I did because
printout was this high.
yeah, did you break it?
Well, it timed out.
Okay.
And this is real wide paper too, this high. I was so embarrassed. I had to take a dolly for the recycling. But it was classic stupid programming, you know? I mean, it was just simple little. Oh, in fact, speaking of a little Boolean statement, this is an AI related thing. Some guys online, and I forgot who they were, they did an AI deal where it produced a whole bunch of combinations of new chemicals. And one of the statements was, is this harmful to humans? And if it was, it would skip that chemical and go on to the next one. Well, and it produced like 15,000 chemicals they haven't heard of before. And then they took that statement out. So it produced everything. And it produced so bad that they got called into Congress
Oh,
and were drilled. And they were saying how evil this is, and they were saying anyone can do this.
uh-huh. Oh, so it made like deadly.
Oh,
I made anything.
bad,
Oh my
bad
God.
stuff.
Oh my God.
You know, like nerve agents that are never heard of.
Oh
before.
my God.
That's what I mean. That's why they got called in. Yeah.
Yeah, but
It
how
was
do you?
mass, weapons of mass destruction.
Yeah, how do you? Because you can't do.
And the bad people in the world are doing that as we speak.
I think like the one thing I saw was like you have to have the good guys get better at AI before you have the bad guys get good at AI. Because like you can't moderate that.
Yeah, but that's
Like,
why
how
we,
long are you gonna?
but you have to have the politics in place to fund all that stuff.
Oh yeah, and then that's
And then,
science.
this class is as basic research. You see, with basic research, there's no real concrete.
Yeah, what's that mean?
That's right. It's just, we're going to study this because it hasn't been studied before. Now, if you write a grant to get that, well, then you have to justify within the grant.
Okay.
But if you're just given money, like that's what's interesting about an undergraduate chemistry degree is very valuable because it's not very valuable by itself, but it's really valuable for graduate school because it's fundamental to a lot, or physics degree, something like that. It's really nice to go into grad school with because then it's fundamental to everything.
Yeah.
But in itself, you're just looking at pure science, nothing applied.
Mhm.
And that's the part, that's why it's hard to get a job that pays anything as a chemist.
Mhm.
And to teach high school, you can just a bachelor's degree, but if you're teaching, higher ed, you have to have at least, well, some kind of graduate degree, at least a master's degree. So,
And then there's not much else you can do as a chemist. I mean, there's probably some stuff.
there's a lot of things you can do as a chemist, but the problem is they don't pay very much.
Oh, okay.
So you spend all this, huh?
Are you like grunt work in a lab?
I'm sorry, say again?
Are you like grunt work? Like you just kind of like in a lab, you just kind of. Well, I don't know. Why does it not pay that much?
Because they can get away with it.
But like you kind of need chemistry, right? So okay,
Yeah, I mean,
are there a lot of chemists doing?
yeah, there are a lot of chemistry teachers. There used to be 8 sections of one Chem A
Oh,
when I first started here. Now there are 2.
Mm.
And that's because they haven't got bodies to teach it. And the other thing that bugs me is a lot of people like to teach Chem A. Oh, it's the basic stuff. The math ability of students is lousy. Well, it's important. It's real important for you to understand how to set up problems, the problem-solving strategies and all this stuff.
Mhm.
Because I know exactly what the weaknesses are of incoming people
Yeah.
into 1A. Unit 1, Unit 2, and Unit 3. Seriously. Unit 4, not so much, but man, especially Unit 2 and Unit 3. They died. They were, and typically in the summer, I get a lot of people making up Chem 1A because they flunked it in their normals. So a couple summers ago, I taught 1A, and I had students from all over the country. And University of North Dakota, a lot of people from Sac State, Davis, San Diego, all over the place. because they're making up, because they flunked. 1A. And they didn't do very well either. They continued their habits.
Yeah.
And that's why they flunked, was because they continued their habits. And my chemistry students all got A's. I had like six or seven. They all got A's. And it was it was a fun class to teach because we were just talking about where they're from and all this stuff.
Somewhere can.
Yeah. So,
Those are names.
so are you guys going to lab today?
I think
I just had a question for it.
Sure.
For lab 12 is the one I didn't do. Send it the nomenclature one. So we're skipping these, right?
Correct.
Right.
And these.
This is what we're doing?
Yeah.
Okay, but how do I know where to find the number of valence electrons? I'm just like looking it up.
No, it's on, so,
I'm still confused about that.
okay, so carbon, you know how many valence electron carbons?
No, that was my
Okay,
question.
so the C has
Count-
4 of them.
Count from the left to the right.
Okay,
How many over is it? It's 4 over.
4 over, yeah.
Okay. And it has 4 singletons.
How do I know that?
Which is,
It's on a chart again.
I know, but is that the only way?
maybe
Is that
you
just like
remember,
something you?
Carbon is kind of carbon is bond hybridization. In unit 4, we're going to talk about more on electrons and orbitals and stuff. The carbon has 4 singletons.
Okay.
And it has 4 valence electrons. Valence electrons are electrons in the outermost orbit. It doesn't count the core electrons, which are inner orbits, just outer, because that determines chemistry. All right, the next one over is nitrogen. Nitrogen has 1 more electron
I think
than
so.
carbon. Okay, so
Because it's
first
one
thing
more
over,
over here.
one of them gets paired up. So you have 3 singletons now in 1 pair.
Okay,
Oxygen has got 2 more electrons than carbon, so it's got yet another paired up. So you have 2 pairs now,
yeah,
2 singletons. Fluoride has yet another electron, so it pairs up. So you have 1 singleton electron and 3 pairs.
so what did the pairs,
So, yeah,
can a pair from an oxygen pair to a pair on the nitrogen?
I think that's
No.
later. Wait, oh,
Okay, and what do those pairs do?
There,
Kind of self,
2 electrons in an orbital are stable.
okay,
oh,
so that means they're not wanting to jump because they already jumped to where they want to be.
Exactly.
Okay,
Now, there's one exception to that. That's if an atom that wants to pair has no electrons.
okay, then it's like a vacuum, I would imagine.
Well, it's just, but it wants to become more stable.
Oh, yeah.
So, what happens is it'll pair with one of the pairs. Like the nitrogen.
Yeah,
Okay, so if you have a hydrogen, for example,
yeah.
that has no electrons.
It needs to,
So it wants to, so what happens is it bonds with a pair.
okay,
if it was carbon, would it just take the 2 singles? Would it just double bond? If it was C,
No, because,
okay, but for
theoretically, yes, but that doesn't happen.
okay.
like bromine, since that's the first one on here, bromine
It's-
2, that's 35.
It's under fluorine, so if you follow fluorine's pattern, it's,
Yeah, so the groups in the periodic table all have the same valence.
Okay,
it's exactly this,
So whatever.
Except
so every
fluorine-
column is,
Same thing.
okay,
the hell.
So when you have,
it would just be on the next outer layer.
yeah, back page of your lab there,
Yeah,
you need to write the structure for that. So that means it's got 4 hydrogens and one of them has no electron.
only one hydrogen has one? No,
Well, that's plus one.
I know,
It
but
lost 1 electron.
and I only had one.
Yeah, so one of the
But
hydrogens.
only one of them, not all 4 of them have.
No, because then it'd be a +4.
Okay, yes.
Okay, so what happens is you have hydrogen here. Hydrogen here. Yeah,
Okay,
and so here you go.
But so if you want to do the first one, So bromine is gonna look like the F. So
Yeah, so bromine's in,
those two in the middle are.
they're
Do
different.
you understand?
So it says number of valence electrons, Br bromine 2. Would I just put 2 for 1 and 1 times?
No,
So I'd still put 1 for even though there's 2?
to fluorine,
How many?
to 7,
Yeah.
and you have 2 of them, so it'd be 14.
Am I thinking, am I combining valence electrons and then singletons?
It's part of the singleton, Jim.
Okay.
I
So
wrote
it's just
two
total-
numbers.
So, okay, so
I wrote two separate numbers for myself. How many singletons?
Yeah, well, the singletons bond,
Yeah.
the pairs don't, except for,
Except for that.
but what about, what is that? Iodine?
Mhm.
Iodine, bromine. So they're in the same row.
Yeah, so it would just look like that.
Yep.
So how many valence electrons?
So it would be the same 14.
Yeah, it would be
14.
the same 14.
Is this gonna give me stuff in like the middle of
No,
the-
it's not. It's only the 4.
Okay, no, okay, that was more of my question. I was like, is it gonna give me like gold? And I'm like, I'm not gonna know what
No.
that is.
yeah, it gets complicated when you start getting down bottom half.
That's what I was like, is it gonna go that far?
Yeah,
And
no.
that's why I was asking. It's like, I'm gonna need to do that. Okay.
Oh, you keep saying alkali earth metals. I thought it was alkaline earth metals
Is there a difference?
for the second, or is it the second?
Either one.
And then it's alkali metals. Yeah. That's cool. Sorry, yeah.
That's
That's alkaline earth metals.
Doesn't matter.
Okay.
It's alkaline for
Okay.
So,
Mhm.
it's like when you read textbooks.
Yeah.
Textbooks now.
No.
For lab 5, the nomenclature one. Are we gonna be given on the test molecules and then we're gonna have to define whether it's a type 1 or type 2?
No, I'm gonna give you a molecule, a structure, name it,
Okay,
and you have to figure out whether it's ionic or a molecular,
okay,
and use the right convention,
yeah,
and then I'll give you a name, you write the formula.
okay. But I just meant like, we're not gonna be having to worry about whether a metal has only one possible oxidation state or if it has several.
Right, but I'm gonna give you a common ion chart as well.
Okay.
So you can tell from that.
Okay,
Oh, hydrogen's a gas, right?
Huh?
Hydrogen's a non-metal, right? I guess.
the two on the left.
Hydrogen's weird. Hydrogen's just, sometimes you'll see hydrogen on the left and the right.
Really?
Yeah, because it acts like on the common ion chart. Remember, there's hydride, H minus, and H plus.
Hmm.
And with acids, it's H plus. With everything else, it's H minus.
I was thinking that because it's a covalent bond when it's like CO2. Sorry, H2O, sorry. That's a covalent molecular bond.
Yeah.
Not a metal one, not a ion.
Right.
We're
But
also
it's on
given
the
a periodic table, right?
Hmm?
We're also given a periodic table.
I always get. Or you're gonna have to.
We'll have to label it, so yeah.
Yeah, every test I give you a periodic table.
Okay.
And then I don't want you memorizing certain things. If you have a smartphone, it's BS to memorize stuff and just look it up. Oh,
But we will have to memorize the suffixes, right? Like if it's the last one, it'd be an "ide" or
yeah, you have to know. And you also, but I have it on the common ion chart.
two.
Mono, di, tri on the top right.
Yeah. Okay. What about any of the eights, ATE suffixes?
That'll be in your common ion chart.
Okay,
It's called a polyatomic ion,
okay,
and those are usually anions. They're basically groups,
yeah,
like CO3 minus 2,
yeah,
NO3 minus 1. But as a group, they're minus 1.
yeah, not
Individually, you know,
or whatever their element is. Yeah. Okay. I don't know, good.
I'm gonna go now. Thank you, Mr. Perkins.
Okay, good talking to you guys.
Wait.